Let me start with a talk about observability of embedded systems. And very briefly about me, my name is David, and I am a developer advocate and a software engineer from Spotflow. And last 2 years, I've been quite interested in observability of software, its principles, and tooling like Prometheus, OpenTelemetry, and so on. And then within Spotflow, I shifted more towards observability of embedded devices specifically. And today, I will not go super deep, but the goal is rather to hint you into like how to approach the problem of knowing the state of devices that are running remotely in the field, in the production phase of the devices, and then I'll show you some useful features and tools that Zephyr offers to achieve that. So, why should you even care? What is observability? The term itself, it comes from math, from control theory, and it is usually defined loosely like that. So it is a property of a system that tells you how well you can infer internal states of the system based on some outputs. And if you break it down, we've got some questions about a system which is the embedded device in our case. And we only have at our hands some predefined outputs, and we also call them signals sometimes, and they can be, for example, log messages, metrics, or something like that we export from the device. And if you think about it, it should at least loosely resemble the reality because the device is running somewhere remotely. You often cannot interact with it directly. And you often also want to know this historical state of the device. So really what you need to do is to define some outputs from the device that you can later inspect. And this is basically the approach of observability. The idea is to systematically design these outputs so they can help you in the future. And that is a bit different to the traditional approach of monitoring, which was much more reactive. You usually would add some more instrumentation, some more logging, some more metrics each time something bad happened, for example, with the firmware or with some software. And the idea of observability is to like prepare right from the beginning some reasonable level of visibility into the system. But okay, let's make it a bit more real. Like, what questions am I talking about? Like, what should we ask? What can we ask? The questions can be very simple, like, is the device running? Has it crashed recently? What was the reason of the crash? Or some performance questions like, is the device interact promptly with the users if it's a device which is interactive somehow? So these are more like technical questions, but we can also ask questions more from the product side of things, like do users even use these features? Should we invest more money into that feature? Or you definitely want to improve the experience of the users, so you would like to know what a typical user is experiencing when they are interacting with your device. Some of these might be irrelevant for a device, some might be more relevant, some less, but this is basically the direction of questions that we strive for. Okay, so how can Zephyr help us to achieve that? So first, Zephyr has a really nice extensive logging subsystem. It has a nice subsystem for core dumps, and since Zephyr 4.0, it also has Prometheus API, which we can use for capturing and exposing metrics. And then there are some utilities that can help us handle failure states, like Task Watchdog API, which is basically a software watchdog. You define a watchdog for each task that you want to monitor, and then you expect the task to send heartbeats back to the watchdog. And if you do not receive the heartbeats in some specified interval, your defined callback is called. So you can handle the failure gracefully. And from the observability point of view, you would probably want to report that to your monitoring platform that something bad happened. A fatal error handler approaches this in a bit different way. It's basically a wrapper around the whole application which catches fatal errors, and again, you can somehow gracefully, for example, shut down the device. You might want to write something to a persistent storage, And then when the device boots up, you might want to report that something bad happened and some details about the crash to the cloud. Let's take a look in a bit more detail to the first three parts. So you probably know how logging works in Zephyr, at least loosely. So we've got some logging macros like log information, log warnings, log errors. This is the logging front end, which is very lightweight. It basically just passes data to the logging core, which then routes the data to logging backends. You can use several logging backends at one time, and there are some built-in logging backends like UART, RTT, MQTT, and you can also build your custom one if you, for example, wanted to send the logs via HTTP or something like that. And it is also nice for observability providers like us, like Spotflow, as we can just offer a logging backend to the users, and they can just plug it in, and it all works. So this is also a nice way how to grow the ecosystem around Zephyr. And one main advantage is also that, of course, the Zephyr modules themselves use this subsystem, so you get a bunch of very useful logs when you decide to collect the logs from the logging subsystem. So the usage is very simple. It's basically like printf or printk. So you can provide some text message. From the observability point of view, you would probably want to add some more context. So maybe something like this. If something is happening during some operation, you might want to add something like operation ID, so you can later correlate the logs that are grouped that are related to the operation, and then some extra contextual data. Now, you might be afraid that you add a lot of bytes to that, but there is also a nice feature of dictionary logging in Zephyr, which basically assigns each log template a number, and then in the compiled binary you basically handle just that number, and you can reconstruct the log for example in the cloud, where you combine a dictionary of these log templates, the number that is assigned to your specific log, and of course the template values. One extra tip is that the formatting of the logs is not happening right when we call this macro. So we actually get everything structured in the logging backends. So we can also route this structured data to, for example, to the cloud. And this can be useful, as for example, if we wanted to query the data, we won't need to use, for example, some regexes to get the data only with some specific operation ID or some specific error value, but we can transform, or we can exploit the fact that we have the structure, and then we can, for example, build querying based on these template values explicitly. Okay. Yeah, okay, what's next? To Zephyr 4.3, there's coming rate limiting. So if you're afraid that your logs will be flooded by some specific message which is in a tight loop, you can use these macros, which rate limits how often a single, basically a log template can be reported. So that's nice. Now we look at metrics. Metrics are definitely not as mature within Zephyr. There is basically no central subsystem like we have seen in logging. But since Zephyr 4.0, there is a Prometheus API which you can use to capture and expose your own application metrics. If you don't know what is a metric in the context of Prometheus, it is just a time series which is pre-aggregated on the device, and it has some name, it has some labels which are basically just key value pairs. And these are the three most basic types of metrics. We've got a counter, which is basically an integer which can go only up. We've got gauge, which is a thing where if you need to go up and down, you would use gauge. So for example, if you want to report the battery level, you would use gauge. And then a histogram, which is usually used to measure duration of some operations. So you can later compute percentiles from the buckets. So these are the basic types of metrics. I don't know if you know Prometheus, how it works. It historically works on a pool-based basis. So you've got a Prometheus server, a Prometheus agent, which needs to call our device via HTTP, and then the HTTP server needs to respond with something like this. So this is the Prometheus API. It is a text-based format. So this might not be suitable for devices, as it has some assumptions that you need to. For example, this must be possible, which might not be, and you might be okay with having the HTTP handling and so on. So if you wanted to use push-based system, so you push some metrics to the monitoring platform that you use, you would need to implement that yourself. Okay, last thing, core dumps. You probably know core dumps, especially from local development, but they can be also very useful when monitoring remote devices, as there is, again, this useful pattern that you can capture the core dump when the device crashes, and then on the boot up, you would read the core dump from the persistent storage, and you can send it to the cloud and then analyze it later in the cloud. Core dumps are captured in fatal errors. There are some native core dump handlers as well, the logging and a flash partition one. And unlike with logging, only one core dump backend can be used at one time. You can, when you capture the core dump, you can analyze it. You can analyze it via GDB or a third-party tool. Basically, depending on the detail of the core dump, you get some information about the threads that failed, or all the threads, or optionally you can also include the global and static variables. And to like each of the level, you can also add some custom regions of memory. All of these have a bit different purposes and a bit different advantages and disadvantages. So it is up to us software engineers to create like a good mix to get reasonable level of observability at least. I would definitely start with logs, as you've seen, the ecosystem around logs in Zephyr is already really nice, and you get a high level of granularity. You can give to the logs a lot of context, so it is really nice for debugging, for some root cause analysis. Then I would use metrics if you wanted to get at least a high level overview of the system. It is easy to define alerts based on the metrics. You can see some trends, and they are not as detailed, obviously, as for example logs, but they are also very cheap, both on the device side and both later in the for example cloud side, on the storage side. And then core dumps, they are a category, let's say, of their own, as they handle the fatal errors, but they have basically no match when you need to analyze that, as they basically are a snapshot of the state of the device at the time of the crash. And they can be a bit demanding if you wanted to send a whole, or a big part of the memory, but this is why core dumps are fine-tunable. And yeah, that's basically it. I hope that I've shown you at least one thing that can make your devices a bit more observable.